Alright, so chapter 8.7 represents the last chapter we are going to do for this quarter, so it is the last two tests that you're going to take for this quarter. We will start the fourth quarter with one more factoring process. Part of that factoring process involves what we're learning today, so make sure you work hard to get it, because otherwise, like I said, you'll be starting the fourth quarter off not so well, which isn't good. But yesterday what I did is I tried to give, for those of you who finished fast enough for me to be able to get you the sheet, I gave you a sheet that explained a lot of what you need to know today's work. The worksheet discussed situations where one of the values B or C equals 0. The problems for today are going to first off focus on when B is equal to 0. When B is equal to 0, it gives a different situation in terms of finding the values. Keep in mind, when we were asked to factor something, we always start off with multiplies to equal something, adds to be something else. And what we learned yesterday was that yes, we still do 9 times -1, so it multiplies to be -9, but when there is no x, it means that is a 0x, which means that it multiplies to be 9 and adds to be 0. Alright, so again, in that situation, if the formula is ax squared plus bx plus c, there is a ax squared, there is a c, but because there's no x, that means that b is equal to 0. And so again, that's where that comes from. Just like this one, we will be looking for numbers that multiply to be -100 and add to b, because there's no x term, add to be 0. And so that is something that was different that I tried to introduce you to yesterday. Again, when we're looking for numbers that multiply to be something and add to be 0, it means that the numbers must be opposites. That's what we discussed yesterday. Many of you worked hard to find the numbers yesterday by finding all the factors or by punching in a whole bunch of different things in your calculator, but there is a much easier way to find the opposites in the factor tree. A while ago we learned that squaring a number means multiplying it by itself. So 5 squared means 5 times 5. We learned that 6 squared is 6 times 6. We also learned, though, later on, and it was still this year, that square rooting is the opposite of squaring, which means that that's identifying a number that multiplies by itself to be a value. So we are going to actually use the square root function because, again, if you do the square root of 4, the reason the answer to the square root of 4 is 2 is because 2 times 2 is equal to 4. The reason the square root of 25 is equal to 5 is because 5 times 5 is equal to 25. So again, square rooting says what number multiplies by itself to equal this number. So you can make a tree looking for opposites to multiply to be 16. That's not so bad because it's not a lot of numbers. 1 times 16, 2 times 8, 4 times 4. But it would take a lot of precious time to find opposites to multiply to be 324. There's a lot of numbers, a lot of buttons that you'd have to press. It doesn't mean that we can't find it for a larger number, but again, our goal is to be efficient and to use our time wisely. So if you're looking for numbers that multiply by itself to make 324 or multiply to be 324 and add to make 0, all you have to honestly do is type in the square root of 324. Remember that's second x squared, 324, which tells me 18, and so therefore I know that 18 times 18 is in the tree at the very bottom. With that topic hopefully under some sort of control, let's look at what you need to actually understand to perform it correctly. So we're going to factor some 3 quadratics with b equal to 0, actually go through the whole thing with the process that you learned. In this case, we are looking for numbers that multiply to be -36 and add to be 0. Again, because it adds to be 0, it means the numbers should be opposites, which means we're looking for the same number that multiplies by itself to be 36. We, of course, know 6 times 6 is equal to 36. That is a positive 6 and a negative 6. It doesn't really matter which one you pick because either way, it's 0, so it doesn't matter where the signs go. You can put a negative over here and a positive over there. It does not matter. Then we learn to go 4x over 6, 4x over -6, which reduces to be 2x over 3, and 2x over -3. That factors out to be 2x plus 3, 2x minus 3, and that would be our answer. Alright? So again, based off of the process that we worked on 2 days ago, and then that we actually quizzed on again or took an assessment on again yesterday, that is the process that you can use. X squared minus 49. Again, in this case, we are looking for numbers that multiply to equal 1 times -49, so -49 and add to be 0. Again, numbers that multiply to, or add to be 0 means they have to be the same. The number that multiplies by itself to make 49 is 7 and 7. Again, it does not matter if I put a negative over here and a positive over there. They just need to be opposites because these two things add to be 0. Then you look at it and you say, well, I put x over 7, negative 7. I put x over 7. Those cannot reduce, so my factors are x minus 7 and x plus 7. Alright. The third one, looking at some big numbers. Here we're looking for numbers that multiply to equal negative 8100 and add to be 0. Again, if you get a big number like that, just do second x squared 8100, and you find out that 90 times 90 is 8100. So you got 90 here, 90 there, again a positive and a negative 90 because it adds to be 0. And so what we do now is we put 100x over 90. We put 100x over negative 90. You reduce those two fractions. Again, if you don't remember how, I hope you remember how, because that was the skill we needed. Math, enter, enter. You end up with 10 over 9, so it's 10x over 9 here, 10x over negative 9 there, which makes 10x plus 9 and 10x minus 9. Again, those are our factors. I know it looks like a slash, but oh well. Remember I said that the point is efficiency. So let's just investigate our results from these three problems. I do hope you wrote some of those down. But let's look at what our answers came from, or how we might have found them. Think about 4. What number multiplies to be 4 would be 2 times 2. There's your 2. There's your 2. Think about x squared. What multiplies by itself to be x squared is x times x. There's your x. There's your x. Think about 9. What multiplies to make 9 is 3 times 3. There's your 3. There's your 3. The only difference is one of them has a plus, one of them has a minus. Let's see if that pattern follows again. X is x times x. Here's your x. There's your x. 49 is 7 times 7. Here's your 7. There's your 7. There's a plus and a minus in the parentheses. 100 is 10 times, I messed up on this because there's a y there, so we need a y here and a y there. Either way, 100 is 10 times 10, so you got your 10 times 10. X squared is x times x, so you got x times x. 81 is 9 times 9, here's your 9 times your 9. And y squared is y times y, and again a plus and a minus on the inside. What that means for us is that if we recognize that numbers in our observation, if we recognize that numbers in our combination add to be 0, first off it has to multiply to make a negative, because if it doesn't, then you can't possibly have opposites. Because think about it, the only way I can have opposites is if they multiply to make a negative. But if you recognize that, then we can use our observation and our common sense to jump a few steps. So let's just see what that means in terms of making our work a little bit easier if we happen to see that. So what I will do with A is I will look and say, hey, this is one of those where it looks like it could be a perfect square, and this is how I would actually work it out. And please don't try to take a shortcut, because you're already taking a shortcut. What I would do is say 25 is 5 times 5, x squared is x times x, 4 is 2 times 2, and because there's a minus involved, that means all I have to do is 5x plus 2 and 5x minus 2. This plus that and this minus that is all I have to do. Alright? 49x squared minus 1. Again, notice that there's no b there, which means that it follows a pattern that might exist. 49 is a perfect number. Let's just see real fast. 49 is 7 times 7. X squared is x times x. 1 is actually 1 times 1. And again, there is a minus in the middle, which means I can do it, so I'll do 7x plus 1 and 7x minus 1. That is all. Even if there's a second letter, which throws some of you off, 16 x squared minus 81 y squared. Again, there's no middle term, but there is a minus in the middle instead. 16 is 4 times 4. X squared is x times x. 81 is 9 times 9. Y squared is y times y, which means I simply put 4x plus 9y and 4x minus 9y. And even with a big number like this, 144x squared minus 121, I know that the square root of 144 is, if you use your calculator, is 12. X squared is x times x. 121 is 11 times 11. And so I put 12x plus 11, 12x minus 11. Let me explain again, because some of you like to not catch on to the limitations of some of these things. This only works when you have a perfect square, and a perfect square with a minus in the middle. Everything has to be a perfect square with a minus in the middle. Alright? Another part of today's lesson brings in our work with finding the GCF. We've been taught to find the GCF. Now what we're going to do is learn to factor out the GCF. The process is simple, but again, it's going to take practice just like anything else. Today's level of work will be set up for you. Tomorrow you're going to have to bring your own level of understanding and try to work to master it. So let's look at some examples as far as what you're going to see, and I'll explain how the computer is going to have it set up and all that good stuff. You're going to be asked to factor out the GCF, and when you see it, you're going to see a blank followed by a parentheses followed by a blank, a plus, and a blank. I didn't make anything negative, so everything is going to be set up for you. I hope I put another parentheses. If not, it's bad programming, but that is the general idea. We know that we're going to factor, which means the opposite of distributive property, and we know that this looks like a distributive property problem. If you remember, we were asked to find the GCF of 16 and 24, so you were told to put the two numbers into a fraction, turn them into a fraction again, so you got a decimal. And then what we did was we took this top number divided by that top number. 16 divided by 2 is 8, which means my biggest number for 16 and 24 is 8. Remember, you could also use number sense, but again, I'm just going over the skill because some of you, I don't think, got that all the way. We also learned that when it came to variables, that in terms of what they have in common, you choose the smallest number, and so 8x squared is what goes out here. We found the GCF. Now what we do is we pretty much take this problem and we simplify everything here to be in here. So 16 was 16, but then we factored out an 8, which means 16 divided by 8 should have turned into a 2. Think about this. You had 6 x's, 4, 5, 6. You took 2 off. That means you now have 4 x's. So this should be 2 because of 16 divided by 8, and x to the 4th because I had 6, but I took 2 off, 2x to the 4th. Plus is going to be there. 24 divided by 8 is 3. I had 2 x's. I took them off. There are no more left. Again, you had 2 x's. You took 2 off. That is my answer. The good thing about factoring out the GCF is you can use the distributive property to check it. 8 times 2 is 16. 2 x's and 4 x's make 6. 8 times 3 is 24. 2 x's all together there finishes it off. Looking at 21 and 14, again, you will see a box, a parentheses, a box, and a closed parentheses, which means the first thing we have to do is find our GCF and pull it out here. 21 and 14, biggest number is 7. Biggest number of x's I can pull out is 6, because there are 8 over here and 6 over there. Again, what we do now is we convert our 21. 21 divided by 7 is 3. I had 8 x's, but I took 6 out. Remember, I took them all off of everything, so again I took 6 off, which means I have 2 left. 14 divided by 7 is 2. I had 6 x's. I took all 6 off. That would be it. Again, a quick check. 7 times 3, 21. 6 plus 2, 8. 7 times 2, 14. 6 x's matches what I have there. If I have numbers again that are a little bit out of range, again, best thing you can do is use your calculator. So I'm going to, again, remember I said the best thing to do is put the fraction in terms of the smaller number on top so you don't get anything crazy. Again, 122 to 61, I believe 122 divided by 61 gives me the answer of 2. That means in my GCF here, if I have, as I have those blanks and boxes, is 2. In terms of x's, the most I can take off are 2 because that's the lowest amount. 148 divided by 2 is 61 with 3 x's left. Again, 5 x's, taking 2 off leaves me 3. 122 divided by 2 I believe is 6, or no, that's not 61. That's 74. So 74 here, I'm sorry, I went off my memory. 74 here because that's 148 divided by 2, this is 61. And then of course if there were 2 x's and I took 2 off, that's all I have left is the 61. 2 times 74, 148. 2 x's and 3 x's make 5. 2 times 61, 122. 2 x's all together means my answer is right. And then on question D, 133 and 147. Gives me answer 19 over 21. I don't know what that is, so again I just do 133 divided by the front number 19, which gives me the GCF of 7. Tomorrow you will do it like this. You'll pull off your 7 and you will say I can take off 5 x's. You'll open your parentheses. You'll convert your 133 by pulling out a 7, which gives me 19. you'll say I had 10 X's, I took 5 off, that leaves me 5 X's. The plus will come down. 147 divided by 7, I believe, is 21. Yep. So your 21 comes down. You'll then say I had 5 X's, I took all 5 off, and you will close it. Alright. So taking that and the fact that you got about 30 minutes, please go to MathXL and begin working on that skill. I think the first half is the perfect squares. The second half is GCFs. Be sure to get practice on both parts today. Again, if time starts to run short, if you see we've got 10 minutes left or so, then skip the first half of it and jump down to the second part where you actually get to work on this skill, because today is an introductory level of that, which means you need to ask whatever questions you need to of me today on this, so that tomorrow we can do a more realistic version of what's going to be on your test Monday. Again, tomorrow is a second day of practice, a full second day of practice, and then Monday is your last test or last assessments of the quarter. So please go to MathXL, begin working on that skill, and again, be sure to get practice on both parts today. If time starts to run short again, skip to the second half. That way you have an opportunity to ask about any issues. Good luck, and again, make sure you are working to keep that momentum. The fourth quarter is coming. Factoring is in some of your fourth quarter work. You might want to make sure we start picking this stuff up. So just let me know if there's anything I can help you with. Other than that, let's get started.